I think that my reason for optimism for people that have, so the big three of peripheral cancers that go to the brain,
right.
Melanoma, non-small cell lung cancer,
okay.
my father,
yeah.
And then breast cancer. And so those are the big three that go to the brain.
Wow.
And
okay.
that area has, I think, really in recent years experienced a lot of growth in the way that they think about the delivery challenge, the new therapeutic space, all of the immune checkpoint inhibitor work that has, been conducted in the last decade plus.
Welcome to the BioTalk Unzipped podcast, where we unzip the stories behind medical progress by sharing the latest and greatest advances in biopharmaceuticals and medical technologies in a fun, entertaining, and enlightening format. And now your co-hosts, Gregory Austin and Dr. Chad Briscoe.
Hi, and welcome to BioTalk Unzipped, where we unzip, unlock, and uncover the stories behind medical progress. I'm your host, Gregory Austin, a life science professional from Kansas City. Today we are in Boston, Massachusetts for AAPS NBC, and it's our pleasure to be here. Today joining us will be Dr. Robert Thorne, who's a Denali Fellow at Denali Therapeutics. Thanks very much, Robert, for joining us on BioTalk Unzipped. It's a pleasure to have you. We're here at AAPS NBC, and you had just given a talk, and there's a lot of activities going on. This is really kind of getting close to the end of day one. And so far from what you've experienced this year in this conference, how is it, kind of meeting some of your expectations from what you're hoping to get out scientifically, and what are some of the things that you would like to share from what you've heard so far?
Yeah, so first off, it's a pleasure to be here. Thanks for having me. I have been to the NBC meeting before, like about a decade ago, and I think this is a little bit more of a generalist meeting, I'd say. So biotechnology, biotech is a huge, vast, field. And, the opening plenary was about oncology and, specifically myeloma. And my talk was on drug delivery to the brain, so putting different people with very different research, scientific, clinical perspectives in the same venue is often like a fruitful, productive exercise. I really enjoy talking with and getting the opinion of people that have a very different take on things. They come from a different background. So, what I recalled of NBC in the past is the same today. My experience over the past 2 days is that, I'm sort of thrown in with a lot of people who have very different perspectives than I do.
Sure.
But I find that, that's useful, that's good.
Yep.
So staying abreast of what's happening in that space is important. So all of that's happened for me in the last 2 days.
That's good. It's interesting you mentioned, you see old friends, people that you've known before, people you might have worked with before, people who might be competitors, but I kind of, I'm a sports guy, so I equate some of these types of interactions that you see in the bioanalysis world. It's kind of like a professional sports league in a way, right? Because the people who maybe your competitors today, maybe your teammate tomorrow kind of thing.
Yeah.
It's a small group, and people are very collegial, and that's what I love about this, this particular part of the industry.
That's very true. Yeah, that's it's and this is true in general in science. That when those of us in a particular field, my particular field is the central nervous system barriers and drug delivery to the brain, and it is we might have a few thousand people worldwide. Right. And over the course of being in the field for, I hesitate to say it, but for like 35 years, I know a lot of those people.
Sure.
And so you're always then, but going to meetings and particularly having a higher profile role, it's also an opportunity for me to meet a lot of trainees. So there are a number of students and postdocs here. So I always enjoy that. It's kind of like, to use your sports analogy, I may have given a talk at, like many times before in different venues and settings in my field, but then there are a great number of people, particularly at a meeting like this, that are being exposed to it for the very first time. So I feel that weight of responsibility, not only to represent my company and the things that we're doing at Denali Therapeutics, but I feel a larger responsibility to represent my field.
Well, it's it is a responsibility and a burden, but it's also exciting as well to introduce some of these new technologies and new research ideas to folks. So speaking of neuroscience and CNS, I have a kind of a personal question. It's not personal for you, but it's personal for me because my father died of metastatic melanoma that got into his brain. And we didn't know anything about it, didn't know he had mental status changes, and until he had the CAT scan and then the MRI, didn't know what was going on. And he had a pretty massive tumor removed successfully. It was right about here, and the tumor actually wasn't as big as the hematoma around it. Because what we learned is that melanoma is really known for causing brain bleeds as well. And so, this is 17 years ago. And that's actually what got me into this industry.
Wow.
I was working for a recruiting agency, and they said, hey, pick a major. You can recruit for any industry you want. And I said, well, I really want to be in the science of biotech and pharma to see, are there any clinical trials? Is there someone who's in the neuroscience field who can help my dad? And I did eventually find somebody who had that experience in neuroscience, but he's like, there's nothing like that now. So 17 years later, in your experience, if you heard about a patient had metastatic melanoma in the brain, what can be done? Is there anything?
So I think, my answer is a mix of that. We know a lot more. I think there's reason for optimism going forward. And then there still is the sort of sobering reality that you said 17 years ago, that the survival rates haven't changed dramatically for metastatic brain cancer. So you and I actually have a real shared history that way. So I said I've been in the field for 35 years. 35 years ago, my father died of adenocarcinoma of the lung spread to the brain.
Oh, wow.
So he had brain surgery multiple times, kind of like your dad did.
Sure. Is that what got you into this field?
That is what got me into the field. So, I think there's a larger sort of message there of, our personal stories and what we choose to do for our professions, how we get interested and first enter into different areas. First off, I'm sorry that you had that experience.
Sure. Thank you.
I
Likewise.
went through something myself like that, so I have some empathy for some understanding of that. And the same kind of thing that my mother and I looked into what could be done. This was in the late 80s. And there wasn't a lot. And I think that my reason for optimism for people that have, so the big three of peripheral cancers that go to the brain, melanoma, non-small cell lung cancer, my father, and then breast cancer. And so those are the big three that go to the brain.
Wow.
And that area has, I think, really in recent years experienced a lot of growth in the way that they think about the delivery challenge, the new therapeutic space, all of the immune checkpoint inhibitor work that has been conducted in the last decade plus. There's a lot of potential avenues you can go. And in all of those cases, with the metastatic brain cancers, there is a pronounced delivery challenge. So there's a heterogeneity that we understand. We understand this from two things: gadolinium enhancement in the clinic. The other really useful paradigm is some of these brain met preclinical models. So if you generate a brain-seeking cancer cell line and you inject it intracardiac into the left ventricle of a mouse and it homes to the brain, it produces a very different kind of metastatic cancer in the brain than it does if you just inject it directly into the brain.
That's interesting.
And the big difference is that the vasculature is different. So you you inject directly into the brain, you generate these sort of golf ball-like tumors, and the vasculature is typically quite disorganized. We know with metastatic brain cancer that is not always the case. So they have, in some cases, a normal blood-brain barrier. There's a heterogeneity. So one MET might be fairly permeable to a circulating antibody, and another MET is completely impermeable. So it suggests that there's a delivery challenge.
Yeah.
And companies like Denali Therapeutics, we are interested in that. And so that is a focus for us. There is, I mentioned in my talk, there's work in the focused ultrasound community for opening the blood-brain barrier, that some of those groups that are practicing that method are interested in metastatic brain cancer, and then certainly primary brain cancer. So the same sort of concept of these cancers being whole brain diseases is there for primary brain cancer like GBM.
Okay.
Because the clinical experience is that in all cases, so GBM, you have surgical resection, radiation therapy, and temozolomide has been the standard of care since temozolomide was described and approved 20 years ago. Doesn't really do a whole lot to extend survival. And so we know that these tumors always recur, and we know that we need additional, we need new therapeutic avenues there. And so a lot of that does come down to the work that I'm doing today, which is new methods of delivery, getting brain exposure everywhere. Ideally, you'd get something that would really potently get you exposure at the site of the tumor in the peritumoral region, but then some degree of exposure that's going to be efficacious in all the distant normal brain. Because the idea that you have cancer cells that have basically broken off and are spreading locally within the nervous system, so that even if you hit the initial sites, then some of the other sites are going to get you in the end eventually. So if you are not able to treat all the cancer in the brain, then likely the outcome is not going to be good.
Right. What was interesting in my dad's case is that he had a tumor removed from his back. And it's a pretty good sized tumor. It's a few inches long, an inch or two wide, and checked every year, fine for 17 years, nothing. And then all of a sudden, mental status changes. And then we had no idea what it could be until they biopsied the tissue.
So two thoughts about that. One is that we know, there's a lot of work in the brain, in the breast cancer brain met field, particularly in the context of HER2 positive breast cancer, that the brain can serve as a sanctuary site. And I think not just the brain, but some other
organ systems as well,
sites in the body. So you can have, people that have been in remission for a long time. Suddenly there's some sort of precipitating event. It could be a viral illness or something else. And then whatever it is, that sort of dormant cell suddenly has the switch to start proliferating. And so I think that there definitely there is that phenomena. It's hard to say after the fact, and like with your father, with my father, what the real sequence of events was. But there's a concept in oncology of seed and soil, and so these cancers like melanoma, your dad on his back, they at some point break off, and you get these circulating cancer cells in the circulation, in the bloodstream. And so that's the sort of initial seeding part, and they go and they're looking for a soil. Some environment that's going to have the right characteristics. And so there is an idea that this is the reason why certain cancers have a certain preference or a higher probability of metastasizing to certain sites in the body, like the brain. So with prostate cancer, we don't say, oh, the brain is a common sanctuary. No, the prostate cancer doesn't typically go to the brain. But melanoma, non-small cell lung cancer, breast cancer do. And so there's that aspect of, so then there are all the things we've been talking about. Each of the areas is a whole fertile research community trying to understand that. What are the aspects of the circulating tumor cells that allow them for, their long-lived nature in the circulation sometimes. For the brain, what are the aspects that lead to their trafficking into the brain? Because if you understand some of those detailed steps, then you can start thinking about intelligent therapies to counteract each of those steps.
Right.
And then, the end result is you're having metastases in the brain that are leading to some kind of some burden that leads to diagnosis. So that could be change in cognition, that could be headaches, that could be any of a number of things. But oftentimes in the clinic, people are discovering these cancers. They're already at a pretty advanced stage.
Yeah, it's already trouble, for sure. I'm just curious, have you heard of a DNET tumor, disoembryoplastic neuroepithelial tumor?
I have not.
Well, it's not cancer, so that's probably why, right? And it's an ultra rare disease that is a benign slow growth tumor that happens in kids. The reason I know about it is because my son had it when he was 6.
Oh.
And he was he was just throwing up just almost every morning. And so we're like, what's going on with this kid? Does he have some type of GI issue? We did pediatrician, GI doctor, nothing. But every time he threw up, he would get confused. He would be like, Tyler, go to the bathroom, and he'd walk past the bathroom.
Tell me the tumor one more time.
Disoembryoplastic neuroepithelial tumor, of DNET for short.
Okay.
And one time he walked into a closet, and so we kept telling our pediatrician, he gets very confused.
You realize something is wrong. Yeah.
All right, let's do a CAT scan. And then they found something which terrified us to no end. It was like the longest 8-9 hours of our lives between CAT scan and result of the MRI, which turned out to be this tumor that, survivability is very, very good. Resection is the treatment, which we had a great pediatric neurosurgeon who had done many of these, because at Children's Mercy they get all the weird cases in the region. So it was just kind of coincidental that my dad has this brain tumor, my kid has this other non-related tumor. It's just kind of crazy.
Yeah, so another area that you're touching on now, that I'm also very much interested in personally is the diffuse pediatric glioma space. So, two tumors, medulloblastoma, which is I think the most common solid tumor of the brain in children, and then diffuse intrinsic pontine glioma, which is number 2. The modern name is diffuse midline glioma. These are tumors that certain types of medulloblastoma, but then all DIPGs or DMGs have this diffusive nature where they really don't enhance with gadolinium, T1 weighted gadolinium MRI.
Okay, yeah.
And gadolinium, the type of gadolinium that's administered in those cases is a small molecule.
Okay.
And so the inference from that is that the blood-brain barrier is relatively normal.
Okay.
The challenge with those cancers, unlike your son's, is that these are pretty, when they're, so the DIPGs and certain types of the medulloblastomas are really fatal cancers. And so we again have this sort of delivery challenge, bottleneck there.
Gotcha.
And in children, they're a lot less, so the surgical resection is definitely an option. Some of the radiation protocols, like in a developing brain, is not something that is ideal.
Correct.
So just massive, large, unmet medical need, again, in that area. And it just, it shows that. So my hope is over time, we learn things from some of the programs we're developing at Denali, some of our other partners and other companies in the field, that collectively as a community, we're going to learn enough and get some successful development in treating adults or treating some of these children with like the lysosomal storage diseases I talked about in my talk, mucopolysaccharidosis type 2 or Hunter syndrome. That some of the learnings from that work are then going to be translated to diseases like these childhood brain cancers, and because the needs are just great. Like if you unfortunately, like suddenly have a child and it's the same for all these parents, right? You have a normal child, and then all of a sudden, like your son, something's happening,
right?
And then eventually, the decision's made to get some imaging, and then you almost like you have this fork in the road where your life dramatically changes in an instant. And
we're just
as
so
a
fortunate.
parent, like I have a daughter. Nothing motivates us more than, typically than when you have a child that is sick and you want to do everything possible to make them better. And, so this motivates me as a neuroscientist, greatly. that we have the opportunity to really, create some therapies that haven't existed before, some options that have not formally been there. And I think that we're at a point now where the biology of the central nervous system barriers and some of the ideas and approaches, the elegant approaches around engineering and the different methods for drug delivery to the brain have matured to the point where I think we're on the cusp next decade, where we're going to see some successes, and the successes are going to make possible more success, because in this industry, as you probably are well aware, success breeds more interest and more funding. And resources and funding is ultimately what's required to develop drugs. It's hard.
It is.
And particularly in the area that I'm in, neuroscience, there's really not that much low-hanging fruit. So you need to do things differently. You need to think outside the box. You need to develop innovative approaches. And then you need to have a fantastic team to execute on the work.
100%. And so the reason, by the way, he was throwing up is he's having many seizures, and the seizure was kind of spreading out, and it would cause him to vomit. But it was weird how that one thing led us to finally get to a diagnosis that was accurate and correct, and fortunately treatable. He's doing great. So we're really lucky.
That's great. That's wonderful that it's been a good outcome for you.
Yeah, thank you. Good.
All right. Well, pleasure talking to you.
Yeah, likewise.
Yeah.
Well, Chad and I would like to extend a very warm thank you to AAPS for all the wonderful support, allowing us to be here and to sort of take over the media room for a while, to have some wonderful conversations with some friends and some new friends and scientists here at AAPS NBC. A special thank you to Rebecca Stouffer, who has been phenomenal in her support and helping all of this happen very smoothly. So we want to thank her, thank the organization, and we look forward to seeing you soon.